Hello, I'm Chuck Martin, and welcome to the Voices of the Internet of Things. With me today is James Nesfield, Chief Executive Officer of Chirp, an audio technology company for connecting devices using sound. James focuses on setting the technology and development direction of the company and coordinating with external partners. Welcome here, James.
Hi there.
So you're in London right now, right?
Yes,
And
Central
that
London.
is that where you're headquartered?
Yes, yeah, we're based completely in London.
I know we were both at the ARM TechCon conference a short bit ago. Unfortunately, we didn't cross paths there. But what were you
Yeah,
doing at ARM? And I'm not sure everyone knows what ARM is, but they're big, obviously.
yeah, sure. So it was my colleague, Dr. Daniel Jones, who's Chirp's chief technical officer, and he was there really demonstrating acoustic networking using ARM's chip, specifically the M4 for audio digital signal processing. So he was there, kind of manning the Chirp demo on the ARM booth, and just really talking to delegates about the possibilities of adding acoustic networking and connectivity through sound to any ARM-powered device, or really any device that has a loudspeaker or microphone.
So let's talk about audio in general before we get into specific sounds. Where do you? I mean,
Sure.
everything today is voice, obviously, with Amazon, Google
hmm
Home, and so forth. Where does voice fit versus sound versus just any other kind of audio? I mean, I know your whole background is in audio.
Yeah, sure. So obviously, voice is really important when we're talking about people and when we're talking about clearly how people communicate, but increasingly how people cooperate with machines around them and devices. The distinction with data over sound is that we're really in the business of getting machines to talk to each other, devices to talk to each other, using the same medium as voice. At the end of the day, it's all moving air particles, but we do it in a machine language rather than a human language. So when devices talk to each other using sound, they're typically sending very short tones, which are played out into the space, and then other nearby devices hear those tones and can decode data. And sometimes those tones are so high that humans can't hear them. They're ultrasonic, but it's still just sound using the same medium as voice. It's all just moving air particles.
So is this what Shopkick was doing years ago when they were doing basically sound beacon sounds? Essentially, when someone walks into a big department store, a signal goes to their phone, an audio signal goes to their phone. Is that an early version of this?
Well, one of the earliest versions, of course, is Morse code, for example. People will be familiar with the dial-up modem. That is data over sound down a phone line. The concept of encoding data into audio is not new. In conceptual terms, of course, but in practical terms, making a technology that can be rolled out in difficult real world scenarios, and which works on a variety of different devices, compensates for acoustic artifacts like acoustic distortions, really like reverberation, and of course noise. That's really the challenge for data over sound that Chirp has solved.
What, can you explain a little bit about what Chirp does? Not sure everyone's familiar with Chirp.
Sure, it'd be good to just give a quick introduction to the company. We produce a range of SDKs for all the major platforms, iOS, Android, Python, JavaScript, you name it. We've got an audio API, but each of these software products really does the same thing at the end of the day. It allows developers and the applications and services that they're building to take some information and to encode it as audio, play it out into the room, and then nearby devices decoding it back into the information. So we just provide the tools to do that, and Chirp is focused exclusively on providing great SDKs for engineers to drop into third-party products and services.
Great. Just for the record, I have no vested interest in this. I just am interested in what you're doing here,
Yeah.
which is why we're doing this podcast. I just think this is a potentially very big deal globally because it's a different kind of thing. It's not Bluetooth. It's not NFC. It's different. How do you do it?
Well, years of research. As you've mentioned, my background is in acoustics and digital signal processing, but really the wider team, including our CTO, Dr. Dan Jones, our background is audio. We live and breathe signal processing, communications, computer science, and acoustics. And so the real smarts are on the decoding side, because on the encoding side and the loudspeaker side, when you're sending the information, that's really just a little synthesizer, quite frankly. That's, relatively speaking, the more simple side of the transmission. On the receiving side, that's where the audio engine has to differentiate between signal and noise and compensate for the distortions that I mentioned earlier. And there we've got, several, unfortunately, quite secret strategies towards making sure that at the receiver, the data is able to be decoded reliably.
Is that technically hard to do?
It is in real world situations that are often quite chaotic, messy, unpredictable. To get a device to listen for a beep and do something when it hears one is somewhat trivial. But to get to the stage that our technology is at, like for example, we've got a project with EDF Nuclear Energy here in the UK, whereby we're doing a ultrasonic acoustic network in their turbine halls. So these are incredibly acoustically harsh environments for a couple of reasons. One, the noise level. You've got all this whirring machinery, but also they're big, large industrial spaces with kind of flat concrete walls, which make reverberation and acoustic reflections a big problem. To send data via sound in an environment where, as people going into that facility, we need to wear ear defenders. That's an incredible challenge, and one which we're really proud to have overcome. Not least to mention, of course, that EDF Nuclear Energy were somewhat concerned with reliability and safety.
An application like that, do you have to go customize it for the location, like with the cement walls and so forth?
For that one, we did. We optimized for that particular use case. And we've got the capability to do that for a variety of different scenarios. But we also have protocols which are kind of more generally applicable as well.
So how did a nuclear agency say, hey, we need to use sound in here? How did that come about?
Well, they've got a unique set of problems, really, in terms of their infrastructure and regulatory commitments, because they are not permitted to use any RF technology within the functional part of their nuclear site. So, that means no Wi-Fi, no Bluetooth, and yet they've got machinery that is often in need of monitoring, particularly for preventative maintenance. And running copper cables is incredibly expensive. So because of the kind of unique set of circumstances that a nuclear facility has to contend with, they thought, hey, maybe we could send these signals using sound and therefore monitor this equipment without having to run expensive copper cable everywhere.
So do they just Google sound and find you?
Yeah. It was not put it this way, it was not a company that we was on the tip of our tongue to approach. Yeah, they approached us and said, "Hey, do you think you guys could help us out here?" And we were very excited about the opportunity to take on that challenge.
Can you talk about some other applications of this, like ticketing or transportation and so forth?
Sure. One of the great things about sound is how widely it's supported, not just on new devices, but on older devices. And so, for applications where you want to have kind of wireless data transfer and a simple user experience, and you want to make sure that you can cover absolutely everybody in your user base. Sound is often a good option there. So we've done ticketing implementations whereby passengers getting onto to a bus in India can validate their ticket using data over sound. And because of the handset demographics there, it was really important that they used a technology which supported primarily Android phones, but often kind of low cost or older models.
So in a case like that, does a consumer with the phone get on the bus or whatever the transportation would say the bus, and then just look at their phone and say yes when they get a signal?
Yeah, it varies. I mean, that's up to the application developer. There's a variety of different kind of user experience options that you can build with our technology at the center. But in each case, all our technology does is get bytes from A to B using sound.
So why would someone use sound in that kind of application versus say a tap or NFC or Bluetooth or something like that?
Yeah, well, it's interesting, right? Because we think that each of these technologies has a place, and we don't claim to replace any of these, but for certain applications, sound as a medium has some unique qualities. For example, on a bus, the sound is restricted to the interior space, unlike a radio frequency technology like Bluetooth, which might go to the adjacent bus at a bus stop. It's also very much more widely supported than technologies like NFC, as you mentioned. It's typically longer range and can do things in parallel in a way that QR codes are often restricted. But we really kind of we look at the future of connectivity in a way so that Chirp fits into a tapestry of connectivity options. And we really think the best user experiences going forward are going to be where the user doesn't really care which technology is being used to facilitate a certain experience, but one in which these technologies are all used in concert. And that's what kind of excites us about the growth in IoT, paired with the growth in voice assistants. That we see, billions of new devices out there in the market space, kind of demanding different forms of connectivity, and you see that not just from Chirp, but you see that from other connectivity technologies like Li-Fi, like longer range alternatives like LoRa or Sigfox. And we look at voice assistants through a Chirp lens as a trend which is putting many more microphones and loudspeakers out there in the world for us to piggyback on top of. That's an exciting place to be. And so IoT in general, we see as a driver for connectivity in general.
So are you going to be inside other things inside cars?
Anywhere there's a loudspeaker, we've got the ability to broadcast data. Cars could quite easily be an interesting space for us to be applied there.
What would be a hypothetical use in a car?
It really depends on the manufacturer and the user experience that you want to create there. It could be that you want to connect passengers more easily. I mean, I know, for example, it's very easy if the owner and his or her partner are connected via Bluetooth, but as a guest, if I want to very easily connect and say and pair with the car in some fashion, Chirp could be used to facilitate that quite easily. You can imagine for ride sharing, for example, sound could play a part in making a very kind of friction-free interaction between a driver and a passenger. There are a variety of different use cases, but as I said, it's much more about looking at the use case first and seeing how sound can play a part, regardless of any one kind of particular domain, be that automotive, IoT, or industrial.
So does the creative use for all of this come from outside your company, since you're really supplying the engine essentially, but someone else has to come up with the use case?
Typically, yeah. We've definitely got some interesting ideas and focus areas ourselves, but what we always do is make sure that our products are sector and industry agnostic. We kind of look at it almost similar to when QR codes were first developed in the industrial sector. You know, they were not developed thinking, well, this will one day they'll be in magazines, they'll be, you know, powering billions of purchases via WeChat. We're very careful to make sure that data over sound is connectivity technology which can be applied to any use case where somebody said, yeah, there's a value add here, regardless of which sector they're in.
Are you finding differences internationally? For example, you mentioned WeChat. Like QR codes are way bigger and more common use in Asia than, say, in the U.S., for example. Mm-hmm. Are you seeing differences internationally with sound?
We are, and it's for different reasons as well. So we're seeing strong applications in India for some of the handset demographic reasons that I mentioned earlier. But interestingly, also we're seeing demand in Europe and the US for slightly different reasons. There, it's primarily to do with privacy. Specifically in the US, we're thinking of legislation like COPPA, the Child Online Protection Act, and in the EU, of course, GDPR.
Right.
And there, our technology is quite interesting to engineers because it allows connectivity, which is completely offline and depending on your architecture, anonymous. So you could connect to mobile devices and have them share a piece of data, even if those devices are in airplane mode. You can create user groups without going to the cloud and associating device IDs with user profiles. So this has privacy implications that are quite attractive for some developers. It's worth mentioning, just that of course our technology never records any audio. It doesn't send audio to the cloud for processing. Everything happens just locally on the device.
So I'm sure you're aware of all the various horror story anecdotes of people tapping into either children's toys or Amazon type or Alexa type devices. Is sound bulletproof from a technological security standpoint?
It can be. It really depends on exactly how it's being used, because the application developer can choose to use it in an open way or can layer on encryption. Or architect their product service in a more or less secure way. So we're careful not to claim that there is anything more or less secure than other technologies as the transport layer in this stack. There, it's really up to the application developers to make sure that they are adhering to best practices. But the good thing about that distance between our responsibility and the application developer's responsibility is that they can then layer on best practices from elsewhere. So a bank can use industry standard PKI, encryption strategies, which Chirp is not expert in encryption. We're expert in acoustics and signal processing. It's about that kind of division of labor and making sure that you're using best practices, regardless of what transport technology, what connectivity technology you're using.
So to simplify, does Chirp, does your sound technology basically simply allow two things to connect?
Yeah, it can do two things, but the beauty of sound is that, of course, it can be broadcast. So that's a really nice feature of our technology, that a single loudspeaker can broadcast some data, and without any more demand on the network, say, any number of devices within earshot can receive the data. So it doesn't necessarily need to be one-to-one. It can be one-to-many. And our SDKs support duplex and multiplexing also.
So that means if there was say a large group of people somewhere at some kind of an event, a certain number of those people were, say, into gaming, a particular game, there could be something on the loudspeaker that only those phones could recognize and activate?
Yeah, exactly.
And then other people would simply, nothing would happen with them?
Yes, exactly.
So this must have an application in gaming.
It does, and actually we've done a couple of projects. One last year with Activision, who wanted to send some customized characters from a PlayStation 4. Actually, I think all the consoles. This was part of their Skylanders game, and they wanted to send one of their Skylander characters from the TV, from the console, to a companion app. And the companion app, typically an iPad, was often offline. Sometimes parents restricted the internet access of their children's devices, and they wanted to do it kind of simply and with no config or pairing or setup. So sound was a great fit for them. Really interestingly, though, after that project went live, what we saw is some emergent behavior from the audience that we hadn't really anticipated. They saw that sound was the mechanism for this transfer, and put two and two together and thought, well, if we upload this to YouTube or to Twitch, and our friends watch those videos with the soundtrack, then they'll get the data as well. And so we saw this emergent behavior that they started sharing characters via these videos. It was a really kind of delightful surprise, but really speaks to the power of sound as this ubiquitous, simple technology that Chirp can leverage all of the existing infrastructure for media playback and sound reproduction that's already out there in the world.
So these are sounds that nobody hears, correct?
In that case, it was actually audible. The Activision Blizzard wanted it to be a bit of an effect, and there it sounded a little bit like R2D2. Of course, if you pitch it up into ultrasonic, the same thing could be done inaudibly.
So you could put something in music then, couldn't you?
Yeah, layered over the top typically. In ultrasound, you can play any audio you want underneath.
So is this like secret sound?
I
don't mean that in a negative way.
Yeah, well, it can be. A lot of our experiences do have that kind of a magical feeling about them, because people assume, especially when you, for example, you put devices in airplane mode, people assume that there's some funny business going on, but of course you just have to explain that no, it's sound that's doing this. And honestly, that's actually a lot of our demos we do with audible protocols, just to really demonstrate the fact that sound really is the mechanism for this action.
Wow. So where do you see this going over time?
Well, we're really excited about there's three real trends here. One is IoT, which I'm sure I don't need to explain to your listeners. The other is familiar as well, which is the real market saturation at this point of smartphones. And then the last, which we've touched upon, is voice assistants. From a Chirp perspective, we see those three trends as really the requirement by billions of smart devices which have audio I/O, which have microphones and speakers, for connectivity. And especially with voice, if we look at the history of human computer interaction, you know it starts with us talking to computers on their terms, right? With punch cards, and then slowly the terminal, and then as we go through the history of how we program and use computers, they get more and more visual, more and more intuitive, and then we arrive at voice, which could be argued is, you know, the most intuitive mode that humans know of interacting with intelligent things around them. We see voice as slowly becoming completely ubiquitous and taken for granted. And through a small software upgrade using our technology, you go from a state where there's microphones and speakers everywhere to enable voice experiences, to one where you also have an acoustic network that can help facilitate, you know, useful and delightful experiences. So we're really, really optimistic about the general trends that are driving audio I/O infrastructure and driving demand for connectivity in general.
Well, audio is clearly not going away. Thank you, James, and thank you all for listening to the Voices of the Internet of Things.
My pleasure. Thank you.